Welcome to our module on cryptography. Today we're diving into one of the oldest encryption methods, the simple substitution cipher. Substitution ciphers are foundational to cryptography, forming the basis for many more complex modern encryption techniques. A simple substitution cipher replaces each letter of the original message, or plaintext, with a corresponding letter from a ciphertext alphabet. This method is categorized as a monoalphabetic cipher, meaning that one letter is consistently replaced by the same unique letter throughout the entire message. The key to this cipher is essentially a jumbled or scrambled version of the 26 letters of the alphabet, which maps the plaintext letters to their replacements. To actually use this cipher, both the sender and receiver rely on a substitution mapping table, which represents this key. The table shows the plaintext alphabet in the top row and the unique ciphertext, or jumbled key, in the bottom row. Reading the table is simple. Find your letter in the top row, and the cipher letter is the one directly below it. For example, A might become M. The core of the cipher involves two processes: encryption to hide the message and decryption to reveal it. To encrypt, you take your original message, find each letter in the plaintext row of the key, and write down the corresponding letter from the ciphertext row. Conversely, to decrypt, you look at the encrypted message, find those letters in the bottom ciphertext row, and write down the corresponding plaintext letter directly above it. A critical requirement is that both the sender and the receiver must possess the exact same substitution mapping table. Without the identical key, the message is useless gibberish. Let's walk through an example and encrypt the word security using our sample key. We apply the key to each letter of security one by one, substituting S for I, E for C, and so on, based on the established mapping table. After applying the key, the plaintext security becomes the ciphertext ICBYOKUQ. Despite its seeming effectiveness, the simple substitution cipher is historically weak and easy to break. The cipher fails because it retains the structural patterns of the original words. For instance, double letters in the plaintext remain double letters in the ciphertext. Crucially, this cipher is vulnerable to frequency analysis. Since E is the most common letter in English, finding the most frequent letter in the code quickly reveals the key, making the whole message fall apart. In summary, the simple substitution cipher, while replacing one letter with another, is weak because its fixed substitution is easily undone using pattern recognition and frequency analysis.